Welcome to my YouTube channel. Today I'm going to be solving let's say Bernoulli equations, like to be working them out, and I'm going to be going step by step. But what you should know here that Bernoulli equations have a relationship with the linear differential equations, of which I'll be dropping a solution in a nearby video. So by this time, let's first work out what a Bernoulli equation is. So suppose I have dy dx plus x squared y, that would be equals to x cubed y squared. So this is a typical example of a Bernoulli equation. It is very different from a linear differential equation by the fact that the variable of y is multiplied to the, because its standard form is, we have this like dy dx. Yes, we are going to have, this is going to be px y, which would be equals to q of x. Then this would be y to power n. So this is the standard form of a Bernoulli equation. Then to work out such an equation, you find that you have to come here. There are two methods that I'm going to be giving you to working out this kind of equation, of which the first method, let me use the first method. So we are going to come to this equation itself and we get it out. And therefore, if I'm having my dy d of x plus x squared y, which would be equals to x cubed y squared. So the first method is that you're going to divide by this y squared throughout. So you're going to come here and say this divide by y squared, divide by y squared, divide by y squared. So after dividing throughout by y squared, come here and say that this would be y to power -2 dy dx. Then plus this would be x squared y to power -1. And then this would be equals to, this would be remain just x cubed. Now having got this, now preferably come here and say that we have to work hard so that we can attain back this, let's like the whole of this. So therefore we are going to let and say that let u be equals to y. Yes, y to will let u be equals to this y to power -1, which to be this. So having done that, we are going to say we are going to differentiate u with respect to dx and this dy dx, and therefore we are going to say that this is going to be du dx, which will be equals to, we are going to have negative y to power -2. That's all. So this is going to be dy dx. So having done that, now we have to make this the subject in which we decide that we can attain an expression of this kind. Therefore we come here and say that this is going to be, I'm going to have negative du dx. Yes, having got that, then I say this would be equals to y power -2 dy dx. Now having obtained this, I'll try to relate with the equation where I did my division. You find that this equation, I can insert this, and I have where I can insert this, whereby in terms of u. And therefore I come here and say that I'm going to have, for this, I'm going to have negative du dx. Then for y to power -1, I'm going to substitute with u, and therefore I'm going to have plus plus x squared u. Then afterwards I say that this would be equals to, then I'm having the x cubed. So if you look at this equation here, I can make it a linear differential equation by working out. So that means that the remaining thing here, I'm going to just divide by this negative, whereby du dx minus this would be x squared u would be equals to negative x cubed. Now, having done that, I come down here of x is equals to x squared. Also, now, but it is having that negative sign in front of it, and therefore it is negative x, and therefore the integrating factor of x would be equals to, I would have e integral the side of, I'm going to have this p of x d of x, and therefore this would be equals to e, let's say I'm going to have here, this is going to be negative x squared d of x. Therefore this would be equals to e, I'm going to have negative x cubed all over 3, and this would be my integrating factor. Having got that, I come here and say that this kind, which would be e power negative x cubed out of 3, yes, u, I put this in the bracket, d all over dx, which would be equals to, remember it multiplies throughout, and after multiplying throughout, I would get negative x cubed, yes, negative x cubed e to power negative x cubed all over 3. Then after getting this, then I come and take this dx the other side, so it would be e to power negative x cubed out of 3, u would be equals to, I'll have the integral of negative x cubed e to power negative x cubed all over 3 d of x. So this kind of integration is integration by parts, of which I made a video about this, so I don't know, we might check it out. It is, I'll be leaving the link within the description, so maybe you might check it out. So if you integrate this, only this one, you find that what you're going to get, we are going to have e to power negative x cubed all over 3 u, which would be 3x cubed e to power negative x cubed all over 3 plus 27x squared e to power negative x cubed out of 3 plus 162 x e to power negative x cubed out of 3 plus 486 e to power negative x cubed out of 3 plus the arbitrary constant. So you find that after integrating this, that's inside here, this is what you're going to get. And after getting this, now remember you're having this and this u here. So what you're going to do is you're going to divide by this. That means that u would be equals to, if you divide this, you're going to get this. You're going to get 3x cubed plus, this one is going to be 27x squared, and if you divide this, you're going to get plus 162x, and if you divide this, you're going to get plus 48.6, then plus. Now remember, this was also supposed to be divided. If you divide throughout, this is also supposed to be divided, and therefore plus c e to power x cubed out of 3. But remember, this u was presenting something. If you remember very well, we're letting u to be represented by representing y equals y to power -1 was equals to u, and therefore that's what we substitute down here. Therefore we come and say that y to power -1, which would be equals to 3x cubed plus 27x squared plus 162x plus 486, then plus we're having the c e to power x cubed out of 3, and therefore your final answer would be 1 out of y, which would be equals to 3x cubed plus 27x squared plus 162x plus 486 plus c e power x cubed out of 3. And then this would be your final answer for this problem. So this is how we work it out, and this is how it comes out. And now, having known that this is the format that is supposed to exist, what we do here, we are going to say that p of x in this case will be equals to x squared, q of x, which would be equals to x cubed, and n would be equals to 2. Now, having identified all of these, I come here and say that the integrating factor of x would be equals to e, here I'm having 1 minus n, close this, d of x. So having got that, I come here and say that this is going to be equals to, I'm going to have e 1 minus 2, which is -1, close this, p of x, of which from our equation, p of x is x squared, then d of x. Now, if I integrate this, I'm going to have e, yes, this is going to be negative x cubed all over 3 as our integral factor. So having got this, I continue and say that now, but I know that y to power 1 minus n would be equals to 1 all over integrating factor, then into, I'm going to have 1 minus n, close this, into, I'm going to have q of x, close this, integrating factor, then d of x, I close this. Now, having closed that, I am substituting. Then I come in and say y, this is going to be, this was 2, so this is -1, which would be equals to 1 all over e to power -x cubed out of 3 into, I'm going to have, this is going to be -1, then q of x, of which from our equation, q of x was equals to x cubed, yes, of which we are going to have here, this is going to be x cubed, the integrating factor, which is e to power -x cubed all over 3 d of x. Now, you're supposed to remember this is integration, therefore we represent the sign, and then even this is integration. So after that, we say that y -1 would be equals to 1 all over e power -x cubed all over 3. Then if we integrate what is in the bracket, and this is integration by parts, this is by parts, so what we get here would be 3x cubed e to power -x cubed out of 3, plus 27 x squared e to the power negative x cubed out of 3 plus 162 x e to the power negative x cubed out of 3 plus 486 e to the power negative x cubed out of 3 plus an arbitrary constant, and therefore this would be equals to y minus 1, which would be equals to this. If I divide this throughout, this would be 3x cubed plus 27 x squared plus this would be 162 x plus 486 plus c e to the power, this would be just x cubed out of 3, and then the final answer for this would be 1 over y, which would be equals to 3x cubed plus 27 x squared plus 162 x plus 486 plus c e power x cubed all over 3, and then this would be final answer for my problem. Don't forget to subscribe, and if you like the video, give it a thumbs up. Don't forget to share and turn on the notification so that you can't miss anything on this channel. Thank you for watching.